Hey everyone, welcome to Tech Unpacked. I'm Emma, and I'm joined by Alex, our resident software architecture guru. Today, we're diving into something that's been creating quite a buzz in AI circles, the Model Context Protocol, or MCP. So, Alex, I've been hearing this term thrown around in my master's program, and honestly, it sounds like it could be a game changer. What exactly is MCP in simple terms?
Great to be here, Emma. So, MCP is, well, think of it as the missing piece that lets AI assistants actually do things in the real world. Right now, most language models are basically trapped in their own little universe. They can chat with you brilliantly, but can't really touch your other applications or services. The Model Context Protocol changes that completely. It's like, imagine if your smartphone couldn't install any apps and suddenly someone invented the App Store. That's the scale of change we're talking about. MCP creates a standardized way for AI models to safely interact with external tools, resources, and services through a client-server architecture. I've been implementing it in a few projects, and it's genuinely exciting to see these models suddenly being able to check your calendar, search your documents, or even control your smart home, all while maintaining proper security boundaries.
So, Alex, I've been reading about this model context protocol thing for AI systems, and I'm trying to wrap my head around the architecture. It seems like it's solving some fundamental problems with how AI tools access information, but I'm not quite seeing the big picture yet. How would you explain what MCP architecture actually is to someone who understands AI, but not necessarily system design?
That's a great question, Emma. Think of MCP architecture like a city's infrastructure. Just as a city has roads, power lines, and water systems connecting everything, MCP provides the infrastructure that lets AI applications connect to various data sources safely and efficiently. Before MCP, if you wanted your AI assistant to access your files, databases, or APIs, you'd need custom connections for each one. It was like building a new road every time you wanted to go somewhere new. MCP standardizes all that, creating a secure framework for AI to interact with different tools and data sources.
Oh, so it's almost like browser extensions, but for AI? Where instead of having to rebuild core functionality, developers can just plug in capabilities through a standard interface. That would be huge for scaling AI applications. Wait, so the host is essentially the AI application itself? And it creates these client connections on the fly when it needs to access different types of information? That's fascinating. It's almost like giving the AI a set of specialized tools it can reach for whenever needed.
That's right, the host is your AI application, the thing users interact with. I built an MCP system last month where the host was a coding assistant that could pull documentation, run database queries, and access GitHub repositories. The beauty is that each client maintains exactly one connection to one server, keeping everything isolated so the GitHub server can't suddenly start messing with your database, for instance. It's like having dedicated roads between City Hall and each service in town rather than one big tangled highway where anything could go anywhere. Makes the whole system much more secure and maintainable.
So, if I understand correctly, the servers are where the actual specialized functionality lives, right? Like one server might handle file access, another might provide web search capabilities, and the host coordinates all this through individual client connections. Um, I'm wondering, how does the AI model know which servers it needs for a particular task? Is that something that's hard coded, or does it figure that out dynamically?
Good question. It can work both ways depending on the implementation. In simpler setups, the host might have rules about which servers to use for which kinds of requests. But in more sophisticated systems, and this is where it gets really cool, the AI itself can recognize what capabilities it needs based on the user's request. So if you ask, what meetings do I have tomorrow? It might realize it needs calendar access and create that client connection on the fly. I've seen implementations where the model generates a plan like, I need to 1. Check calendar, 2. Format response, and the system automatically connects to the appropriate servers. It's like having an assistant who knows exactly which expert to consult for each part of a complex task.
So, we've been talking about the protocol architecture in MCP, but I'm still wondering, how do all these components actually talk to each other? Like, when a host needs to communicate with a client or server, what's actually happening under the hood?
That's a great question. This is where the message system comes in. Think of it like a postal service specifically designed for AI applications. It defines standard formats for messages, makes sure they get delivered correctly, and handles errors when things go wrong. Without this system, your AI tools would be like people speaking totally different languages trying to work together.
Hmm, a postal service for AI. That's an interesting way to think about it. So if I'm building, let's say, a coding assistant that needs to access files on my computer, the message system is what allows it to request and receive those files. Could you walk me through what that would look like in practice?
Exactly. Let's use that coding assistant example. So imagine you're writing some Python and your AI assistant needs to read your existing code to give you smart suggestions. First, your assistant needs to request the file content from your computer, then it needs to receive that content and finally process it to give you recommendations. Without the message system, your AI would be completely blind to your files.
That makes sense. But how does it actually um, structure these messages? Is there a standard format? I'm trying to picture what the actual communication looks like.
The message system is built on something called JSON RPC 2.0, which is basically a lightweight protocol for sending structured data between applications. There are three main types of messages. First, you have requests. These are messages that ask for something and expect an answer back. They always include an ID field, which is like a tracking number. Second, you have responses, which answer those requests and include the same ID. And third, you have notifications, which are one-way messages that don't need any response back.
Oh, this is starting to click now. So it's kind of like REST APIs, but specifically optimized for AI tools to talk to their plugins? The request are response patterns sounds familiar, but I like how notifications are built in for when you just need to broadcast something without needing a response. That's actually pretty elegant.
You've got it. That's a solid comparison. It is similar to REST APIs in some ways, but designed specifically for the unique needs of AI applications. I've implemented this in several projects, and what's remarkable is how it standardizes these interactions. Before MCP, everyone was building these connections differently. Now, once you understand this message format, you can build tools that work with any MCP-compatible AI system. It's like we finally have USB ports for AI instead of everyone creating their own proprietary connectors.
So we've been talking about how the message system works in MCP. Requests, responses, notifications. But I'm wondering, how does all this actually start? Like, how does a client even know what capabilities the server has before they start exchanging these messages?
That's exactly where lifecycle management comes in. Think of it like a phone call, Darren. There's a clear beginning where you dial and greet each other, the middle where you have your conversation, and then an end where you say goodbye and hang up. MCP connections follow the same pattern. Without this structure, it would be chaos. Imagine trying to use features the server doesn't even support.
Oh, I see. So there's like a protocol for starting the protocol? That makes a lot of sense, actually. So what are these phases exactly? I'm guessing there must be some sort of negotiation happening at the start?
Exactly right. There are three distinct phases. First is the initialization phase. That's where the client and server introduce themselves, agree on which protocol version to use, and negotiate capabilities. Second is the operation phase. That's the normal communication we talked about earlier with all the requests and responses. And finally, there's the shutdown phase, where the connection ends gracefully instead of just, well, crashing.
Wait, so during initialization, does the client just say, hey, here's what I can do? And the server responds with, cool, here's what I can do? Is there some sort of handshake that happens to make sure they're compatible?
You've got it. I actually call it the initialization dance. The client sends an initialized request with everything it supports, or it's chaos like, I understand protocol version 2024-1105, and I can handle these specific capabilities. The server responds with what it can work with, and then the client sends an initialized notification saying, great, we're on the same page. I implemented this in an AI file browser last year, and without this step, the AI had no idea if it could watch for file changes or just do basic operations.
So this is why plugins can work reliably. The AI knows exactly what each plugin can do before trying to use it. That's actually really clever. What happens if something goes wrong, though? Like if the connection drops suddenly?
That's a great question. This is why the shutdown phase is so important. In a perfect world, either side can send a shutdown request saying, I'm done, let's wrap this up, and resources get properly cleaned up. But MCP also accounts for unexpected disconnections. Servers need to handle clients disappearing without notice. I learned this the hard way when building a smart home integration. If you don't handle lifecycle properly, you might leave zombie processes or locked resources behind. Good lifecycle management is like good manners. It's about saying hello properly, having a good conversation, and saying goodbye when you're done.
So, Alex, we were just talking about lifecycle management in MCP, and I noticed the next concept is something called routes. Is this related to file systems? Like root directories in Linux or something different?
Good question, Emma. It's actually pretty similar to that concept. Roots in MCP are basically about setting boundaries for where AI systems can operate in your file system. Think of it like hiring a personal assistant to organize your files. You wouldn't just give them unlimited access to your entire computer, right? You'd say, hey, you can only work with files in these specific folders.
Oh, so it's kind of like sandboxing for AI assistants? That makes a lot of sense, actually. Because I definitely wouldn't want my coding assistant digging through my personal photos or financial documents while it's trying to help me with a project.
Exactly. It's a security and privacy boundary, and these roots are just URIs, usually file paths like file, yimar, home, last user, in projects, luats, myapi. So when you're building an application with MCP, you can explicitly tell your AI assistant, look, you can access these project folders to help me code, but nothing else. I implemented this for a client recently who wanted AI assistance with their codebase, but had strict data privacy requirements. This was the perfect solution.
Wait, so how does this actually work in practice? Does the developer have to manually specify these routes, or does the user choose them when setting up the AI assistant?
It's actually a bit of both, depending on how you implement it. Technically, there's a three-step process. First, when a client connects to a server, it declares that it supports routes during initialization, then the server can request a list of routes, and finally, the client provides those routes. In a typical application, you might have a UI where users can select which folders they want to give access to, and those choices get translated into route definitions behind the scenes.
That's really powerful. I'm thinking about all the applications where this would be useful, like imagine a research assistant that can only access your papers folder or a coding tutor that only sees your learning projects but not your work code. I feel like this solves one of the big concerns people have about AI tools. The how much access is too much question.
Absolutely, and what's exciting is how this fits into the bigger picture of responsible AI development. These routes create clear, understandable boundaries that both developers and users can reason about. I've seen teams use this to build really powerful AI tools that users actually trust because they know exactly what the AI can and cannot access. It's not just a technical feature, it's a trust building mechanism that might help with broader AI adoption in sensitive environments like healthcare or finance.
So, Alec, we were just talking about routes in MCP, which are basically defining where servers can operate. But now I'm curious about these resources I keep hearing about. From what I understand, they're about sharing information between servers and clients. How does that actually work in practice?
Exactly, Emma. So think of it this way. Routes set the boundaries for where servers can go, but resources are what the servers can actually share with clients. Imagine you're using an AI coding assistant. For it to be truly helpful, it needs context, right? It needs to understand your code files, your project structure, maybe even your database schema. Resources are MCP's way of making all that possible. They're hmm, like a library of reference materials that the AI can access to better understand what you're working on.
Oh, so it's almost like we're giving the AI assistant access to specific documents or files that it can reference? Wait, that sounds really powerful, but also potentially concerning from a privacy perspective. How does the system know which resources to share, and how are they organized so the AI can actually find what it needs?
Great question. Resources are organized using URIs, Uniform Resource Identifiers. Think of them as addresses or catalog numbers for each piece of information, so your Python file might be file, large projects, API. Your database schema could be Postgres, database, users, schemas, and so on. The beauty is that the client, your AI assistant, can actually discover what resources are available by making a simple request to the server asking, what do you have that I can access? The server responds with a list, and then the client can request specific resources as needed. And on the privacy front, you're absolutely right to be concerned. That's why servers are explicitly configured to share only certain resources. Nothing is automatic. You maintain control over what information is accessible.
That makes so much sense. So different types of information, files, databases, docs, they're all accessible through this standardized interface. It's like browser extensions, but for AI. Instead of having separate systems for accessing different data types, everything follows the same pattern. But I'm wondering, what does this look like in real-world applications? Can you give me an example of something cool this enables?
Oh, I love that analogy. Browser extensions, but for AI. That's spot on. In the real world, this is absolutely game changing. I built a coding assistant for my team that can not only reference our code base, but also our internal documentation and API specs when a developer asks, how do I implement feature X using our payment API? The assistant doesn't just give generic advice. It pulls up our actual API documentation as a resource, reads our existing implementation patterns from the code base, and generates examples that follow our team's conventions. Before MCP, this would have required building custom connectors for each data source, but now it's all standardized. I've even seen companies building assistants that can access your calendar, email, and company knowledge base simultaneously to help prepare you for meetings. The possibilities are genuinely mind-blowing when you think about it.
Wait, so you're saying with resources, AI assistants can actually connect to live systems? Like, they're not just trained on static data anymore, but can pull in real time information? That completely changes what's possible. I'm thinking about my research project now. I could potentially create an assistant that accesses our experimental results database and helps interpret findings while also referencing relevant papers we've collected. This is exactly the missing piece I've been looking for.
Exactly, you've got it, and your research application sounds perfect. The static knowledge from the model combined with dynamic, up-to-date resources from your specific context, that's where the magic happens. I had a similar epiphany when I first implemented this. There was this moment where my assistant pulled up some code I wrote just minutes before to answer a question, and I thought, this is it. This changes everything. And the best part, the standardized approach means you don't have to reinvent the wheel for each data source. Build it once, and then adding new resources is straightforward. For your research project, you could start with just the paper database, then add experimental results later, and it all works through the same interface. Yeah, it's honestly one of those architectural patterns that makes you wonder how we ever lived without it.
So, we were just talking about resources in MCP, which help language models access shared information. But I'm really curious about tools. From what I understand, they let AI actually do things rather than just know things, right? Like, that seems like a huge leap forward.
Exactly. That's the perfect way to think about it. Resources are about the AI consuming information, but tools are about the AI taking action. It's like, imagine if you were talking to a friend who could only recall facts they've memorized versus that same friend suddenly being able to check their phone, make calculations, or send messages on your behalf. It's a completely different level of capability.
Oh, wait, so it's almost like browser extensions, but for AI, where you can plug in different capabilities depending on what you need the AI to do. So instead of being limited to what the model was trained on, it can check real time data or perform specific functions.
That's a brilliant analogy. Yes, exactly like browser extensions for AI. Without tools, an AI can only make educated guesses based on its training. But with tools, if you ask what's the weather in Tokyo right now, it doesn't guess based on historical patterns. It can literally call a weather API and give you the actual current conditions. I implemented this for a client recently, and seeing their reaction when the AI went from saying, I don't have real-time data, to providing precise up-to-the-minute information was incredible. Their whole perception of what AI could do for their business changed in that moment.
That's fascinating. So, how does the AI know when to use these tools? Like, does the developer have to explicitly program if weather question, then use weather tool, or is it more flexible than that?
Great question. The beauty of modern LLMs is that they can figure out when to use tools based on their descriptions. You don't need rigid if-then rules. Instead, you provide a tool definition that includes a name like get weather, a description explaining what it does, and an input schema that specifies what parameters it needs, like location. The AI then learns to recognize situations where that tool would be helpful. Think of it like explaining a tool to a smart new employee. You tell them what it's for, and they figure out when to use it.
So, the AI has this menu of available tools and their descriptions, and then, wait, this is blowing my mind a bit. The AI itself decides, oh, this question requires current weather data. I should use the weather tool. And then it automatically formats the request with the right parameters. That's incredibly powerful.
Exactly. And that's why it's such a game changer. The AI identifies the need, calls the appropriate tool with the right parameters, gets back real data, and then incorporates that into its response. We've built systems where a single AI assistant can check inventory databases, process payments, schedule appointments, and send confirmation emails, all through different tools. And the really cool part, when you add a new tool, you don't have to retrain the model or write complex integration code. You just define the tool, and the AI adapts its capabilities immediately.
So, we've been talking about tools in MCP and how they let AI models interact with external systems. But I keep hearing about prompts in this context too. Are these the same prompts we use with regular LLMs? Or is this something different in the MCP framework?
That's a great question, Emma. In MCP, prompts are actually something quite specific. Think of them like reusable recipe cards for language models. You know how a good recipe has a title, description, ingredient list, and steps? MCP prompts work similarly. They're structured templates that servers can offer to help guide interactions with the language model in consistent ways.
Oh, so instead of writing out detailed instructions every single time, developers can create these templates that users can just invoke? Like, if I wanted to build a code review assistant, I could create a standard review my code prompt that users can just call without having to explain what code review means every time.
Exactly, that's a perfect example. Without these structured prompts, users would be crafting those instructions from scratch repeatedly. But with MCP prompts, your server can offer a code review prompt template where the user just needs to provide their code as an argument. Behind the scenes, that template might contain carefully crafted instructions about code quality, best practices, and security considerations that guide the AI's response.
Wait, so it's almost like function calls, but for natural language interactions? Where the function is a template for how to talk to the AI about a specific task, and the arguments are the specific things the user wants to accomplish with that template.
That's a brilliant comparison. It really is like function calls for natural language. The server declares what functions or prompts it supports through the prompts list endpoint, each with defined arguments. When a client wants to use one, they just need to provide values for those arguments. The server then hydrates the full prompt template with those values before sending it to the language model. It's a powerful abstraction that makes complex interactions much more consistent and user-friendly.
I can see how this would be super valuable for specialized applications. So, in implementation terms, how does the server actually set this up? Does it need to define all these prompts upfront, or can they be added dynamically?
Great question. Implementation-wise, you first declare prompt support in your server capabilities. Then you set up a handler for prompts.list requests that returns your available prompts with their metadata. And yes, you can absolutely update these dynamically. Your server can add, remove, or modify available prompts based on user context, subscription level, or whatever makes sense for your application. When prompts change, you just notify clients through the prompts are list changed event. I've built systems where prompts adapt based on user expertise level. Beginners get more detailed templates with extra guidance, while experts get streamlined versions.
So, we were talking about prompt templates, and I'm starting to see how MCP makes those standardized. But I'm wondering, what happens when a server needs to actually get a response from an AI model? Like, if it's not just about structuring the input, but actually needs the AI to generate something?
That's exactly where sampling comes in. Think of it like this. Prompt templates are about how you ask the question, but sampling is about actually getting the answer. It's basically a way for servers to say to the client, hey, I need to ask the language model something, but I don't have direct access to it. Can you help me out?
Oh, so it's almost like the server is borrowing the client's access to the model? That's pretty clever, actually. Does that mean servers don't need their own API keys or direct connections to these language models?
Exactly. That's one of the beautiful things about MCP's architecture. The server can leverage AI capabilities without needing API keys, managing rate limits, or handling billing. Imagine building a bug-fixing tool. Your server might spot potential issues in code, but instead of maintaining connections to OpenAI or Anthropic, it just sends a sampling request through the client, which handles all the model interaction details.
Wait, so how does the flow actually work? If I'm a user running some MCP-enabled application, what's happening behind the scenes when sampling occurs?
Great question. It's a really elegant flow, actually. First, the server creates a sampling request with the messages it wants to send to the AI. Then the client, which could be a VS Code extension, a browser, whatever, receives that request and might modify it based on user preferences. The client then sends it to whatever language model it has access to, gets the response, potentially reviews it, and finally sends the result back to the server. The key thing is the human-in-the-loop design. Users always maintain control over these AI interactions.
That's fascinating. It's almost like the server is saying, I need some AI brain power, and the client acts as the broker or intermediary. But wait, what if the server wants a specific model, like GPT-4 for complex reasoning or Claude for longer context? Can it request particular models or capabilities?
Absolutely. MCP has this really flexible preference system built in. The server can basically say, I'd prefer GPT-4 for this task, but I could also use Claude if needed. It can indicate priorities like speed versus intelligence, but here's the important part. The client makes the final decision. So if a user only has access to certain models or has a preference set up in their client, that takes precedence. I've built several systems where we request the most capable model for complex tasks but fall back gracefully to smaller models for simpler queries. It creates this really nice balance of power between servers, clients, and ultimately the users themselves.
So, we were just talking about sampling in MCP, which is how servers request completions from language models. But now I'm curious about this concept called elicitation. Is that like when the AI needs to ask the user something specific?
Exactly. Elicitation is basically how MCP enables AI systems to ask users for specific information during a conversation. Instead of front loading all questions like a clunky form, it lets the AI ask for exactly what it needs, precisely when it needs it. It's what makes interactions feel natural rather than mechanical.
Oh, that makes sense. So, it's kind of like instead of an AI assistant bombarding me with 20 questions up front, it can have a normal conversation and just ask for my shipping address when we get to that part of the process.
You've got it. Think about how humans naturally converse. We don't demand all possible information up front. If I'm helping you book a flight, I might first ask where you want to go, then when, then about preferences. Elicitation brings that same natural flow to AI interactions. It's actually one of my favorite MCP features because it solves this really awkward UX problem we've had with assistants forever.
I'd love to hear a concrete example of how this works in practice. Like, how would a developer actually implement elicitation in their application?
Sure. Let's say you're building an AI coding assistant that helps users create new projects. A user says, I want to create a new web app. Now, instead of guessing or giving generic instructions, your assistant can use elicitation to ask, what would you like to name this project? What? How about? And once they answer, it might ask, which framework would you prefer? React, Vue, or Angular? Each question comes exactly when needed in the conversation flow.
Wait, so technically speaking, what's happening behind the scenes? Is there a specific format for these requests? And how does the user actually respond?
Great question. Behind the scenes, an elicitation request has two main components, a message that explains what information is needed and why, and a schema that defines the expected data format. The server sends this request using the elicitation create method. Users can then respond in three ways. They can accept and provide the information, explicitly decline, or just cancel by closing the dialog. The system supports simple data types like text, numbers, booleans, and selection lists to keep things straightforward.